Okay, so today's 6.2. It's still going on about division. It's just gonna talk about equal groups, which is something we've learned before. I'm gonna make it a little bit smaller. All right. So it's how can you model division problems and find how many equal groups? So the problem says Hector has 12 rocks. Hector has 12 rocks from a nearby state park. He puts an equal number of his rocks in 3 boxes. How many rocks are in each box? First off, we got to find how many rocks are in each box. So rocks in each box. When you multiply, you put equal groups together. When you divide, you separate into equal groups. Okay? So we have 12 counters. And then what we're going to do is we have our 3 boxes. So which is going to draw 3 circles on the math board, and then one at a time until we count 12. So we don't have our math boards, we have our paper. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, if we'd multiply, we'd have 3 groups with 4, 4, and 4. So it would be 3 times 4 equals 12. But we're dividing, okay? So basically it's how many is in each box. There are 4 counters in each group, so there are 4 rocks in each box. Be like this, actually. 4 times 3. And remember, 12 divided by 3 equals 4. All right, so the next page. Madison has 15 rocks. She puts an equal number of rocks into 5 boxes. How many rocks? First off, we draw 5 squares for 5 boxes. So we have 1 box, 2 boxes, 3 boxes, 4 boxes, and 5 boxes. Now, how many rocks do we have? We have to draw 1 counter in each square to show the rocks. We do 1 at a time until we count 15. So remember, 1 in each until we get to 15. So 1 rock, 2, 3, 4, 5. And I like to kind of put them in the same place in the boxes each time, so I kind of know where I left off. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 3 counters in each group, so there are 3 rocks in each box. And this division problem is actually 15 rocks divided by 5 boxes makes 3 rocks in each box. And if you go backwards, we can take 3 rocks, multiply it by 5, and we'll have 15. How many counters did we draw? We drew 15. How many equal groups did we make? We made 5. And there were 3 in each. Number 1, John has 8 counters. He makes 4 equal groups. Draw a picture to show the number of counters in each group. So we have 8 counters, which are what we're going to count out, but we have 4 groups to put them in. So group 1, 2, 3, and 4. Now we have to put 8 in this. So not 8 in each, 8 throughout these 4. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 counters divided by 4, which is going to be 2. And also, we know that 2 times 4 equals 8. Okay? It can't look like 4 divided by 8 because we can't take 4 and spread it across 8. Remember, the bigger number is always first. Bigger number is called the dividend, and the dividend, and the smaller number is the divisor. The equal groups is what's doing the dividing. The counters is always what's first. Use counters to draw a math board. We can look at it like this. 10 divided by 2 equals what, or what times 6 equals 24? There's 2 ways to look at it. So this one, the top one's kind of easy. To really figure this out in your head is, I'm gonna do my equal groups on the side and then we'll talk about it. So we have 2 equal groups and we have 10 counters. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 5. And that also says 5 times 2 equals 10, which we know is true. So now, think about it. If we skip count 6, how many times does it take to land on 24? So if you have 6, 12, 18, 24, it's taken 1, 2, 3, 4. And I know 4 times 6 is 24. If we were at school, we'd have our marker boards out and you'd be able to see this a little bit better. Same thing here. 14 counters, 7 groups. Well, if you skip count 7, how many times can 7 go into 14? 7, 14. So we have 1, 2. 21 divided by 3. We have 3, 6, 9, 12, 15, 18, 21. So we have to count 1, 2, 3, 4, 5, 6, 7. It's like that. Now, if you did have an extra sheet of paper to really see this, you could draw 3 big circles and count 21 out, and it would still show 7. Number 6, Cameron and Jody collected 20 stamps. Cameron says they can put an equal number of stamps on 5 pages of their album. Jody says they could put an equal number of stamps on 4 pages. Whose statement makes sense? Well, they each have 20 stamps. Cameron wants to put them on 5 pages, and Jody wants to put them on 4 pages. Well, if this can make sense, then they're both correct. So we got to ask ourselves, can 5 go into 20? Can we skip count 5, or can we make 5 groups and put 20 in and not have none left over? That's really what it wants us to look at. So let's try. So here's my 5 groups for Cameron. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, it can. There's 4 in each group. So he can do that. But let's say that was 21. I put 21 up here. Guess what? The first page would have 5 while everybody else would have 4. So that would not work. They all have to have the same amount. Now, let's do 4 groups. So I have 4 groups, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That would work. So both make sense. And look at this. 4 times 5 is the same as 5 times 4. They both equal 20. We can see commutative property in that. But if they use 5 pages, they'll put 4 on each page. If they use 4 pages, they're going to put 5 on each page. And that'll account for all 20 photos. Madison puts all of her photos in a photo album. She puts an equal number of photos on each of 4 pages in her album. How many photos are on each page? So here's Madison. She has 28 photos. She wants to put them on 4 pages. Okay. Let me draw our. Let me actually just open up this. So if we look at 4, let's look at our 4s. Because this is 28 divided by 4. Let's count how many it takes to get to 28. So we can't count this one because this is the actual number. So 4 times 1, it would take 1, 2, 3, 4, 5, 6, 7. So the answer actually is just 7. You got to count 7 times of 4 to get to 28, because 7 times 4 is 28, and 28 divided by 4 is 7. Okay? And if we would draw our 4 counters and count 28, we would have 7. There's multiple ways to go about this. Joe and Ella combine their photos. So Joe has 15, Joe has 25, Ella has 15. If we combine them, let's see how many they have. 5 plus 5 is 10. 0 carrier 1. 1 plus 2 is 3. Plus 1 more is 4. So they combine their photos, and they put an equal number of photos on 8 pages. So 40 divided by 8. Okay? So I could draw 8 groups, and I could count 40 out. That's a good way to do it if we have our math boards. But we don't have a math board. So what I'm going to do, I'm going to pull up my multiplication chart. I'm going to find 8, and I'm going to see how many times I have to count to get to 40. 1, 2, 3, 4, 5. And look, 5 is the magic number. 5 photos. And if you would have an extra sheet of paper laying around and draw your 8 counters and put 40 in each, you would have 5. If you didn't have 5, you did something wrong. Rebecca found 28 seashells. Can she share the seashells equally among 6 people? So 28 divided by 6. Now we can do one of 2 ways. Let's go to a multiplication chart. Let's find 6. And let's count down to 28. 1, 2, 3, 4, 5. Wait, I don't see 28 here. 6 can't go into 28, so that's kind of fishy. That throws me a red flag. So I'm going to go back and let me draw my 6 counters. 1, 2, 3, 4, 5, 6. So I have my 6 counters. 6 groups. Surely I can put 28 in this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Wait, I don't have any more left. There's no more to go on. There's 5 here and there's 4 in the rest. So 28 divided by 8, or 28 divided by 6, cannot be divided equally. 28 divided by 6 cannot be divided equally. We looked at our multiplication chart. We looked at our groups. There's not enough to fill all of these equal, okay? Okay, 28 divided by 6 cannot be divided equally. Number 10, Zaina has 9 rocks from a trip. She puts them into 3 bags. How many rocks are in each bag? So we have 3 bags. We have 9 rocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many rocks are in each bag? 3. Not in all the bags, in each bag. Each bag has 3 rocks. So if you guys have an extra sheet of paper around or a little marker board, this is great to practice on. Draw your 7 groups, put 21 in it. Draw your 7 groups, put 28 in it. You know, it's a lot of work, but it's actually pretty good. But another way you could do it is, pull up a multiplication chart. Let's think. Here's 3, and I got to count to 15. So 3, 1, 2, 3, 4, 5. I go over and make sure. Yep, it is right. So here's 7. I got to make 21. So I go to my 7. I make 21. 1, 2, 3. There's 21. Let me double check. 3 it is. So it would be 3. And so forth, okay? That's how you do that. The same thing here. 12 eggs, 4 different recipes. 12 divided by 4, 27 divided by 3. And make sure you label eggs, flowers. I did it for you. And then this one, we have 18 strawberries, and we want to divide them between 2 friends. So all we have to do is draw 2 groups and count out 18 between the groups, or between them. Draw 2 groups and count out 18, and we can do that real quick. Here's group 1, group 2. So we want to figure out 18 divided by 2, because 18s are counters. 2, we have 2 friends. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if I go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like that. Your lesson check will be online. I think you guys can pretty much handle this one. There's no estimation. Yep, good deal. All right, you guys, this is a pretty quick lesson. You guys have a good one.